Today we're going to talk about forms of energy and conversion of energy. You're going to want to take notes on your note outline, fill in the blanks as I go through this part of the first thing we'll talk about is the fact that we can use an example, an analogy, an experience that I enjoy a lot to describe the different forms of energy. A rock concert. I really enjoy music. I definitely like rock music. Definitely like going to concerts. So there's a lot of energy, and we're going to look at how the forms of energy go throughout a rock concert. And one of my favorite bands, the Foo Fighters here, Dave Grohl. So the first thing we'll talk about is mechanical energy. Mechanical energy, if we kind of look at Dave drumming here, as he was first a drummer, we know that mechanical energy is involving movement. Now we know kinetic energy involves movement too, but we're going to say that mechanical energy is focused on potential and kinetic energy added together. We'll talk about this a little bit later in a roller coaster example also, but roller coasters, rock concerts, you can't beat these examples, right? It's found in objects that are moving, which of course the drumsticks are moving, or have the potential to move. And if you think about mechanical energy being the sum of the kinetic and the potential energy, and drumming, the sticks of the drum are doing a lot of things. Now think about how the kinetic and potential energy is affected as Dave Grohl raises and lowers his drumsticks. Because we know that potential energy is all about the stored energy and location. So when he raises his drumstick and lowers it, he's converting back and forth. Kinetic energy is increasing, and then it's converting into potential energy is converting into kinetic energy constantly as he's moving his hands up and down and his feet as they hit the bass drum, and that's the hi-hat there. So that's pretty cool to think about the constant conversion of kinetic to potential and potential to kinetic, not to Connecticut. And that really, the roller coaster is kind of the classic example, but this would definitely be another one. Chemical energy is, there's a million ways to look at chemical energy. Chemical energy is defined as the energy that is stored in the bonds between the atoms of compounds. And chemical energy is when the bonds are broken, the energy is going to be released and converted into some sort of, for us, usable energy. So that energy can be very usable to us. Now, when you go to a concert today, many musicians are going to use some sort of microphone that doesn't require any sort of wire. So as you can see here, Bono has his microphone, and there's no wire on that. And Edge, the guitarist here, he's not hooked into, his guitar is not hooked into, it has a wireless device. All these wireless devices and Bluetooth and all that have batteries. And you're using a computer right now that has a battery. Your phone has a battery. These are all things that have, batteries involve chemical energy. Side note, also, the food that you eat is a great example of chemical energy too. When you eat food, you have chemical energy stored in sugar. So it's a great example too when you think about chemical energy. Electric energy. Electric energy is pretty exciting stuff. I mean, obviously, anything at a concert has electricity, and it's going to be powering it, whether it be this guitarist here playing his guitar and using electricity to make sound that's very distinctive of an electric guitar, but also, when you think about the energy of moving electrons and a current, electric current, many of the devices at a concert, including lights and electric guitar, like I said, just about everything. Electromagnetic energy. Electromagnetic energy, the cool thing about concerts is a lot of times they have, like I said before, lots of lights and cool effects. Usually concerts are at nighttime, so we need a lot of lights and also just sort of kind of cool effects to make it an experience. So electromagnetic energy, what we define it as, is energy that travels through space, and it's in electrical and magnetic waves. So we care about visible light. Visible light is the one we care about. And so visible light, along with X-rays and microwaves and all those things. Next is thermal energy. Well, thermal energy concerts are usually pretty hot, and so it would be easy to view some thermal energy because you got people packed in a small area, and maybe they're dancing, maybe they're singing, but moving a lot. So thermal energy is defined as the energy of moving atoms of matter, the total potential and kinetic energy of all the microscopic particles. And as you can kind of see here, we're constantly talking about potential, kinetic. We're talking about the sum of those, the changing of those. There's just a lot of energy transformations going on here. So these people should put away their phones and enjoy the show. Anyway, that bothers me. All atoms are constantly moving, so all atoms have thermal energy, which is important. So if you have an atom that's moving, it has some sort of thermal energy. And this is actually something we'll talk about a lot more as we continue to go on into the next part of this unit, thermal energy and heat. The more a mass, the greater the thermal energy. So that's pretty tough to understand, but if you think about, we'll talk about this later too, a swimming pool at 50 degrees Fahrenheit would have more thermal energy than a bathtub full of water at 60 degrees. You're saying, what? Well, it has to do with mass. We'll get into that later. Next, sound energy, the part we enjoy at a concert. It's a form of mechanical energy. Mechanical energy is coming up over and over again here. And vibrations of matter are important, whether that be the vocal cords of this singer, Dave Matthews, or the guitar strings. The vibration of those things would make that. And think about how the drum is going to vibrate, and a snare drum, and a cymbal, and again a bass drum, a bass guitar, and all kinds of vibrations of matter are going to move the air, and those hit the particles in the air, and we can hear them. And of course, it's loud. It's very loud at a concert. That's why he has ear protection in right there, and protecting himself from the very loud sound energy. Last but not least, doesn't really have to do anything with a rock concert, but hey, we've talked about nuclear energy before, so we can include it. Nuclear energy is the energy stored in the nuclei of atoms, the very first unit we went over this semester. And of course, we know that the strong force that holds the nucleus together can be released by splitting the atoms. That fission, not fusion, that splits the atoms and gives us lots of energy. We know that there are lots of opportunities for nuclear energy. There are a lot of advantages to nuclear energy, and of course there are some disadvantages that we discussed way back in the beginning of this semester. And hey, I'll take a stretch on this. Nuclear energy can be used to power a rock concert, as far as we know. Maybe the last rock concert I went to was powered by nuclear energy. Probably not, but maybe. So cool. Make sure you got your notes filled in here. Make sure you're continue to work forward and do all the things you need to do to stay on top of ICP.